Okay, I wanted to make a video with the example of the midterm with the solution. I kind of wanted to go through the solution with you and just kind of talk about some things to look for and some strategies for solving. So this is the sample midterm. I would highly suggest that you go through the sample midterm on your own before watching this video and also before looking at the solution, because I'm about to show you the solution for the sample midterm. Okay, so the first problems here, I can scroll down just enough, I don't know, we'll see. Okay, it says calculate W and D, and I guess it doesn't show W very well there. Where is that? Oh, here it is. Yeah, you have to see this picture. Calculate W and D so that the total moment about A is equal to 0. Hint, determine the equivalent load from the given loads first. So yeah, that's what I would first do. Is you have 3 distributed loads. There's a triangle on top, and then there is on the bottom, there's 2 different rectangular distributed loads. The triangle, remember to get that, it's 1/2 base times height for the area of a triangle. The base is 3 meters wide. The height is 200 newtons per meter. So if you do 200 newtons per meter times 3, you get 600 newtons, and then you multiply that by 1/2 and you get 300 newtons. And so that's why you see the 300 Newton force right here on top. Now it's 2 meters away. How did I get that? Well, the rule with the triangle is that it's 1/3 from the high side. So the high side of the triangle would be the right side because that has the most force, 200 newtons per meter, and it'd be 1/3 of the total distance from that. So since the total distance across is 3 meters, 1/3 of 3 is 1. So it'd be 1 meter from the right or 2 meters from the left. Okay, 300 newtons. Now this one here on the bottom, 37.5, is pretty easy. That's 75 times 0.5. And then the other one is just W times D. I don't know how much it is. Okay, now this is static, so the amount that's pushing down has to match the amount that's pushing up. So since we have 37.5 up plus WD up minus 300 down, that has to equal 0. So you know that the product of W times D is equal to 262.5. So I know W times D is equal to 262.5, but that does not help me solve W or D. Alright, so then I got to sum the moments about A. Alright, so I sum the moments about A, and I have 37.5, the force here at the bottom left, times its perpendicular distance to A, which is only 0.25 because it's very close to A. Then I've got this WD force, okay, which is 262.5. What's its perpendicular distance to A? Well, it's 3 all the way across minus the little bit of area here for WD, which would be D over 2. So it's 262.5 times 3 minus D over 2. And lastly, the top force, 300 newtons times 2. And that would be negative moment because it is clockwise. Okay, the other 2 moments are positive because they're counterclockwise about A. But the 300 Newton force goes clockwise about A, so therefore it's negative. Now we solve this and you get 3 minus D over 2 equals 2.25. Therefore, you're able to solve it. D over 2 is equal to 0.75. Therefore, D is 1.5 meters. So D is actually much larger than what you think here from the picture. It's actually halfway across. So it's basically half the bar. D is 1.5 meters. Now, since you know that, you can now solve for W. Turns out, since WD equals 262.5, you can solve and you get W is equal to 175. So it's a good problem. It's basics, just moments, forces, distributed loads, real simple stuff. If I do a distributed load on the midterm, it's going to be either a triangular distributed load or rectangular distributed load, okay, or a combination of both, okay. I'm not going to do anything crazy where there's going to have to require calculus or anything like that. It's just going to be a triangle or a rectangle. All right, now let's talk about problem number 2. It says determine the moment O from the 20-pound force, okay? And you notice right away that this is a 3D problem, okay? If you are in 3D, you want to use R cross F. You don't want to try to break up this force, this 20-pound force, into components and then try to figure out which way is clockwise or counterclockwise. You do the component method for the 2D problems, not for the 3D. Okay, for 3D, you've got to use R cross F. That's just the way to go. So how do we do it? Well, we have to figure out how to turn this 20-pound force into IJK components. So how do we turn the 20-pound force that goes from B to A into IJK components? Well, what you do first is you say, okay, what does it take if I were to travel from B to A just from the lengths? Okay, if I travel from B to A in the X direction, it's 3 feet over, 3I. If I travel from B to A in the Y direction, I'm clearly going backwards in the Y, so it's clearly going to be negative. How much? Turns out it's 3 cosine 20. How did I get that? Well, if you take a look at the door here, this dimension right here at the bottom of the door is 3 feet, and then it's 20-degree angle here. So the amount of Y direction on the floor is going to be 3 cosine 20. So it's minus 3 cosine 20 to go backwards to A. And if you go to the K, it's going to be 4 minus 3 sine 20 because it's a total height of 4, but you're coming from a height here of 3 sine 20. So it's 4 minus 3 sine 20. So then I do the math, and I actually divide this out. So this is where I create the unit vector. Okay, how did I get this number? I took this and I divided it out by the length. Okay, how did I get the length of B to A? Well, I did 3 squared plus 3 cosine 20 squared plus 4 minus 3 sine 20 squared. Okay, and for that I created the unit vector. I got that length. Okay, I got that unit vector. This has a magnitude of 1. Now, because I have a magnitude of 1 here, I can multiply that by 20 and I can create my force vector. Okay, on the test, I'm sure you'll have something where you'll have to do this, where you'll have to take a vector and turn it into IJK components like this. Now, all you have to do to calculate the moment is just R cross F. Okay, now remember, what is R? Okay, R goes from the point you want to sum moments about, which is O. So you have to start at O, and then you have to go to any point on the line of action of the force. So what are the points that are on the line of action? Well, you could go from O to B, or you can go to O to A. I think it's easier to go O to A. Okay, it's in the same plane, pretty easy. In fact, O to A is 3I plus 4K. So that's easier. So choose O to A to keep it simple. You could also do O to B. There you go. There's the cross product, and then the rest is right there. Now, remember, this is a totally acceptable answer for a moment about O. It has IJK components. If I ask for the magnitude, though, if I said, give me the magnitude of the moment about O, you'd have to take the square root of the squares here. And you have to do square root of 44 squared plus 12 squared plus 33 squared, roughly, right? And you would get the magnitude of the moment. Okay? But this is totally fine. IJK components, good answer, and there it is. Moment about O, pound feet, there you go. All right. Let's go to number 3. All right. So it says the boom AB supports 2 vertical loads, F1 and F2. If F1 is 800 newtons and F2 is 350 newtons, determine the tension in cable BC and the horizontal and vertical reactions at the pin at A. Okay? The very key thing, free body diagram, right? This is a 2D problem, and so generally the best way to do it is to break it up into components. Now the easy part is that force F1 and F2 are just straight down, so that's very simple. And reactions at AX and AY, you just draw them like that. The other thing I would recommend, though, is with this tension T, is to break it up into components. You want to break it up into 4/5 T to the left and 3/5 T up. That'll make life a lot easier to break this angle here into components that are pure left, right, and pure up, down, pure X, pure Y. Then all you have to do is write some forces in the Y, some forces in the X, and some moments. Now you can pick any point you want to sum moments about, okay? I chose A here. You could have chose B as well. B would have been fine. Okay, you could sum moments about B. Okay, the nice thing about summing moments about B is you have lots of forces that go through B. Okay, if you want to choose B, great. I chose A. All right, the reason I chose A was that the only unknown is tension T, and so I could directly solve for tension T using A, point A. If you use point B, you're going to have 2 unknowns because you're going to have AX and AY here. Okay, nothing wrong with that. You'll just have a little bit harder solution. All right, so that one's not too bad. Make sure you know how to do that. All right, now we got this one. If the bucket and its contents have a total weight of 20 pounds, determine the force in supporting cable DA. Again, this is very similar to what we just did. You've got here, you've got to go D to A, you've got to go D to C, okay, and then you write this out. Now, some people get confused about D to B, okay? D to B is just purely in the y direction. So the force that's dB or BD, I don't care which way you do it, is just going to be negative y, okay? That's why if you look some of the forces in the y direction here, I just have minus FBD right there, okay? You don't have to do that one. That one's really simple. It's just purely negative y. The other two, though, you have to write out. First, where'd they go? Then you create the unit vectors, and then you multiply the unit vectors by the unknown forces. And now you've got 3 equations, 3 unknown, and you've got to solve it. The way to do that is a matrix, or use your calculator if you have a solver in your calculator that can do multiple equations, multiple unknowns. But don't be surprised to see something like this on the test. You should be able to do this with your calculator and use the matrix, okay? By the way, just to let you know, solving this is only a small part of the points, okay? Most of the points are in setting this up. If you can't solve this, that's only going to be a couple of points. So don't get too hung up on it. In fact, if you run out of time, don't waste time trying to solve stuff. Just set it up. Because if you can write out some forces X, some forces Y, and some forces Z, and write these equations out correctly, you're going to get a lot of points, okay? All right, so it turns out you can solve that. Very good practice. Make sure you know how to do this with your calculator. All right, problem number 5. Determine the angle between two vectors. And it says if a force 50 newtons acts in R1 and 100 newtons in R2, determine the resultant force. Okay? Again, we've been going through these a bunch of times. The angle, okay, how do you do the angle? Well, you got to write R1, R2, all right, and then you do the dot product between the two, right? And there's a lecture that I go through this, and there's an equation here which you will have this equation. You do not have to memorize this. But basically the angle theta is the inverse cosine of the dot product divided by the magnitude of each vector. The magnitude of R1 is the length of R1. It turns out that's 5 meters. The magnitude of R2 is the length of this vector R2. Turns out that that's 7 meters, so that's very easy. And then you do inverse cosine, you get the angle. Now, in terms of actually getting the forces here, you got to add them all up, and you got to do all that, and it turns out R1 plus R2, or I guess you could call it F1 plus F2, okay, is equal to that. Okay, so that's pretty easy. Again, practice that over and over and over again so you can do that really fast. Okay, you need to be able to take stuff that's from a certain dimension point here and here and turn that into forces IJK and solve them, add them up and solve. Okay, so that's the test. Okay, there's a lot of things there that you should be able to do. Your homework should be a good practice. If you want to do more problems, I'm sure the book has more things, but this is excellent. I hope that you can do this test, and I hope this helps you get ready for the exam.